In this exercise, we're going to practice the basic aggregation and grouping functions in pandas. We're going to use the Gapminder dataset here. First question is asking us to run the descriptive statistics on the data. Once again, this is a very useful function to use, the function describe, because it allows us to have a very kind of high-level summary of our data to understand the structure of the variables that we have in here. For instance, we know how many observations we have. If we take a look at here, we can see that we have observations ranging from 1952 to 2000. It's useful to take a look at the variables and the descriptive statistics for each. Next, this question is asking us to calculate the average life expectancy per continent. So we can do data.group by continent, take the life expectancy, and then run the average, which is the mean aggregation function, and we have the average life expectancy per continent. Next, this is asking us to calculate the average life expectancy per continent per year. It's basically an extension of this one, but instead of having one key here, we will have two keys, continent and year, and we'll run the mean of life expectancy. As you can see here, we'll get a series containing the average per continent per year. And if you take a look at this series has a multi-index containing two levels, the continent and the year. If we would like to convert this to a data frame for presentation purposes, let's call this one S. What we can do here, instead of having just a series, we can unstack. And let's say I want to unstack here, and I will get a table here because year will be converted from being a level on my multi-index to be an axis, which is the column axis here. So we will have this in a table. Again, this depends on the specification that you've been given, and it's a useful option if we have a multi-index, two groupings that we are operating, two keys in the grouping that we're operating on. What's the average length of country name per continent and year? I mean, honestly, this is not a very useful question because who cares about the length of the country name, and the country name doesn't really change. Well, it may change, it only changes if the country changes its name. Or a country drops from being a country in a continent in a certain year. This question is interesting because it's forcing us to write a different aggregation function. So there are two approaches here we can do. We can either we can create another column here called country name length. Let's call it country NL. So I'm going just to take data country and then apply len. Now data.head give us an idea, so we can see that country NL. What's the average per continent per year? So we can do that same thing here, data.group by continent year. Instead of life expectancy, country NL dot mean, and that's the result here. Okay, so that's kind of doing it by creating a third column. The other way to do it is to basically write our own aggregation function. So what I'm going to do here, I'm going to go to my group by operation here, data group by continent and year, and take a look at country. That's a group by series object. Now, if you convert this object to a list and just take a peek at the first item in this list, you can see that the first item in this list is Africa in 1952, and Africa in 1952 contains a series of countries' name. So what I want to do, I want to take this series and calculate the average length of each country in this series. So what I'm going to do here, I'm going to, maybe here above, I'm going to define my aggregation function. And my aggregation function should take a series of string. That's the X here, series, let's call it series of string. And what I want to do with the series of string, I want to calculate the length of each one of them. So I'm doing length X S for S in series of string. That's basically length of Algeria, length of Angola, length of Benin, and so on and so forth. Put them in a list. And then at the end, I'm going to return the sum of all of these lengths over the number of countries, which is basically the length of either the lengths or the series of strings. Doesn't make a difference here. What does that mean? It means that this function here, my aggregation, will take a list of things. So let's say, for instance, UK and France, and it's going to give me 4 because UK, let's count the character, let's count 2. 1, 2, 3, 4, 5, 6. 2 plus 6 is 8, divided over 2 countries. On average, this list of countries contain 4 characters each. Okay, so that's my aggregation function. And then what I'm going to do here, instead of creating a new column, I'm going to do the grouping, pull the named countries, and simply speaking, just aggregate using my aggregation function. And I should get the same result here. So again, writing this custom aggregation functions kind of requires me understanding what's going here under the hood. And under the hood, when I do a group by, I'm getting, where is it? I'm getting a list of groups, a sequence of groups per each country, per each year, and each one of them is a series of country names that I can process in the function. Now, number 4, what are the countries in which the average life expectancy was greater than 75 years? So what we can do here, we can group by country, and then take life expectancy, and then do mean. That'll basically give me the average. Now, I'm not interested in all of them. I'm only interested in those that have an average which is greater than 75. So let's call this one average life expectancy. And I'm then going to mask this series. I'm going to say, okay, average life expectancy, life is greater than 75, and this is going to give me the country names here. Obviously, if I'm interested in the country names, I can do index, convert it to a set, whatever. But those are the countries: Iceland, the Netherlands, Norway. So I can do, let's do it, set.index. The countries are Iceland, Netherlands, Norway, Sweden, and Switzerland that have an average life expectancy over all of the observations, over all of the years in this data set, more than 75. There are different ways of getting to the same result. So let's do it using what we know about using the grouping. Well, first, I'm going to create a custom transformation. I'm going to do group by life expectancy, but instead of doing the mean, I'm going to transform each observation to a Boolean. Okay, so what I'm going to do, I'm going to transform each observation, life expectancy, which is X, to be a Boolean, depending on the mean of the group, 75. That will give me a super mask here, and I can use my super mask to mask my data, and that will give me only data about these countries, as you can see here. So what I can do here now that I have done this, let's do this. I can pull country and then convert it to a set. And that will give me the same result. The other way to do it is to do it through filtering, filter the groups themselves. So I'm going, and again, this is transforming each observation. Next, I'm going to select each observation here. So what I'm going to do now, I'm going to group by country, life expectancy, instead of transform, I'm going to filter. And well, of course, I don't have this concept of a mask anymore, because what I'm gonna get here, I'm gonna get just a series of values of life expectancies for these countries that have a mean over than 75. I don't know the countries, which is here kind of a bit puzzling, but it shouldn't be surprising because I use countries to do the group and I'm only looking at life expectancy. What do I have here is basically the index. So that's the index of these observations in the original data. So I can take a look at that index, and this is the index of these data points. Now what do I do with this index? I use it to index my data frames, kind of like fancy indexing. Well, it's super fancy now, pun intended. Luck of that index is going to give me these countries, and again now I can pull the country and take the set of this operation here. Regardless of what way you go, probably this will be the most easier to understand route, but that's just to show that you can slice through the data in different ways once you understand the kind of dynamic of doing aggregations, what's going under the hood.